So to kick this video off, we are given that two triangles are congruent. And now there's actually 6 possible consequences. Let's say in your proof you get to this point. You say, okay, triangle ABC is congruent to triangle DEF. Or maybe that's even given to you. Most of the time, you'll have to work toward getting there. Let's say you make this congruent statement, maybe you even use a postulate. After you say that the two triangles are congruent, that means that every corresponding part is the same. Every corresponding angle is congruent and every corresponding side is congruent. So we actually get, think about it, let's do the angles. We'd say, oh, angle A, that goes with angle D, the first letter in each congruent statement. Similarly, angle B is congruent to angle E, the second letter in each statement, angle C, and angle F, the third angle in each statement are also congruent. And so these are all consequences. So, if you say triangle ABC is congruent to triangle DEF, let's say by side, 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 the next line in your proof you could say something like, oh, well, angle A is therefore congruent to angle D. Why? Since corresponding angles of congruent triangles, you've already proved the triangles are congruent, that was already given to you. You can say that angle A is congruent to angle D since corresponding angles of congruent triangles are congruent. Similarly, you could say something like, okay, well, AB is congruent to DE, or BC is congruent to EF. Just kind of going through the lettering here, the outer two letters, AC, is congruent to the outer two letters, DF. And if you're told that, if you're given this, then you could say something like, oh, well, AC is congruent to DF. Why would you say such a thing? You'd say, since these are sides, corresponding sides of congruent triangles must be congruent. If you proved or we're told that the triangles are congruent, then every corresponding part is. All the corresponding angles are congruent, and all the corresponding sides are congruent. So now we're going to kind of add, perhaps, let's say, a last line to your proof. After you prove triangles congruent, you're going to have to prove either something about the angles or something about the sides. And here will be your two possible justifications. So now as the proofs start to get a little bit more complicated, what I recommend you do is kind of sketch out your proof even before you write it, because otherwise you might run into some trouble. So for instance, let's just kind of go through the givens. Now keep in mind, this is what we're trying to prove. We need to get there. That's not given to us. We aren't being told angle M is congruent to angle T. But if you think about the last slide that I just talked about, the last line of our proof, once we prove the triangles are congruent, saying, by some postulate they're congruent, our last line, I can tell it to you right now, it's going to be, therefore, angle M is congruent to angle T because corresponding angles in congruent triangles are congruent. That's where we're going to end. But so let's start at the top. They tell us angle I is congruent to angle P. Oh, that was nice. They just gave that to us for free. Okay, so that's going to be one part of our proof. So that'll be given. We'll write that out. They also tell us that D is the midpoint of MT. If D is in the absolute middle of MT, then that means that we get two equal parts making up MT. Okay, and then also by the diagram, you should already be able to see you're going to have some vertical angles being congruent here. You can even tell, even before we do the proof, that we're going to do angle, side. See how the angle is in between the side and the angle? This is known as angle, side. Angle, side. Okay, so we already know our proof. Now we have to write it. So that idea of pre-thinking and doing the prep, doing the rough draft is super important. So now we can fly on this proof. So there's our given for free. Circle it. Now this we're going to have to think about a little bit. We are also given, so we have our second given. Now you got to think about what that means. We already marked in that if D was the midpoint of MT, we know MD is congruent to TD. We just need to say why. So as a result, MD is congruent to TD. Now, you can't assume we know why you know what you're saying. You have to really explain yourself. So we just said D was the midpoint. That was given to us. Now, as a result, we say MD is congruent to DT. But why? There needs to be a since or a because. Since, well, I don't know what midpoint means. You got to tell me. So since, what does a midpoint do? A midpoint, it bisects or it splits. A midpoint cuts a line segment into what? Into two congruent parts. So you knew the definition of a midpoint. You said, you gave me a midpoint, I know what it means, and I know that I get some corresponding sides that are congruent. Okay, last but not least, remember we said we had some vertical angles here. So in addition, that's another good transition word. Remember, you've got to use this in English class. So in addition, and in science class you should be writing well all the time. In addition, we can say that angle MDI, remember we mark that in, MDI was congruent to angle TDP since, we have two lines intersecting. So that's because since vertical angles, well, what about vertical angles? You can't just say since vertical angles. Well, because vertical angles are congruent. Okay, we've got our three components. Last but not least, we can say the two triangles are congruent by angle, angle, side. And you're going to need to do this. You'll actually have to pay attention now to your congruent statement because they didn't give it to you. So therefore, we'll go MDI. That's through the double tick to the center, out to the single tick, through double tick to the center, out to the single. That'll be TDP by angle, angle, side. So you're probably used to proofs ending there. You're used to that being what you're told to prove up here. But instead, we can now lastly say, as a result of this congruence, as a result that we prove the two triangles are identical, angle M is congruent to angle T, we finally are at the end. Since why? Well, these are angles. If you say these two triangles are congruent, then that angle has to go with that angle because corresponding angles of congruent triangles, you just proved the triangles are congruent in the last sentence, must be congruent. And then you're done. Very good. So just like in the last proof, we're going to kind of sketch things out first. So this first given up here, it says we have circle O. Right when you hear that you have a circle, you should be thinking something like, maybe we'll even do a little scratch work. We should say, if O is the center, we know we're going to say that SO is congruent to CO. You should be really thinking, circle? Well, I know that radii are congruent. Okay, so that first clue is going to give us the radii are congruent. They say IO is perpendicular to SC. We know perpendicularity gives us right angles. And then we would say that right angles are congruent. Okay, we also, we were only given 2 bits of information. Remember, this is our goal. We're trying to prove that this big triangle is isosceles. We'll think about what that means in a moment. But we can also look at the picture. So, we've got we're going to have our right angles that are congruent here. IOS and IOC. And last but not least, IO is congruent to itself. That'll be the reflexive property. So that one was just from the diagram. Okay. So now we would say the triangles are congruent. We know that's going to be by side, angle, side. So the angle is in between. It's in the middle of the two sides. So you will say we've got side, angle, side here. So prove the triangle is congruent by side, angle, side. Last but not least, we got to prove this big triangle is isosceles. What the heck does that mean? Well, we know an isosceles triangle has 2 sides that are congruent. Well, so this is going to be 2 steps. The first thing we're going to say, once we prove the triangles are congruent, we can then say, well, to make this isosceles, this would need to be congruent to this. And that would be a result of proving that the triangles are in fact congruent. We would say, oh, IS is congruent to IC because corresponding sides of congruent triangles are congruent. Once we say that's true, then the last line would be triangle ISC is isosceles because isosceles triangles have two congruent sides. And then we're done. So now let's write it up, and I'm going to kind of pause a lot in between sentences so that this can kind of go quick. Okay, so we start off with our first given. We are given circle, that's called a circumpunct. Circle O, that means O is the center of the circle. So we're given circle O. When we hear circles, we think of radii. Thus, SO is congruent to OC since radii of a circle are always congruent. Similarly, we are given we are given that IO is perpendicular to SC. We know that perpendicularity gives us right angles. So we can say, since perpendicular lines intersect to form right angles, perpendicular lines intersect to form right angles, we know that IOS and IOC are right angles. So if they're perpendicular, they're right angles. Thus, those two angles are the same, or they're congruent. They're both 90 degrees. IOS is congruent to IOC since right angles are congruent. Now this should feel familiar because we already went over this idea. Perpendicularity yields right angles, and all right angles are congruent. So we're 2 for 3 here. We had our radii being congruent. We had our right angles being congruent. Last but not least, also, comma, from the diagram, IO is congruent to itself by the reflexive property. Okay, so we have our 3 bits of info here. Remember, we kind of had our scratch work up in this region. So now we can say triangle. Thus, triangle IOS is congruent to triangle IOC by side angle side. Remember, that's what we kind of had deduced beforehand. The angle is in between the two corresponding sides that are congruent. Okay, so the triangles are congruent. We've got to show they're isosceles. And remember, that's that last key. We're going to say, well, if these two triangles are congruent, then IS is congruent to IC, and then that'll mean we have isosceles triangles. An isosceles triangle, a big one. So since corresponding, these are going to be sides of congruent triangles are congruent, IS is congruent to IC, and that's that little extra step that we did in the last proof and that we also did in the motivating example for this problem. We've proved the triangles are congruent, so then the sides that match up must be congruent. And last but not least, therefore, triangle ISC is isosceles, I'm running out of room, is isosceles since, and you have to tell me why. Remember in the last line you said IS was congruent to IC. Well, why does that make it isosceles? Well, it's isosceles since it has two congruent sides. And then you're done. Do the little, shade the little boxy thing. Now this one's for you to do on your own. Make sure you copy it down. Really use example 1 and example 2 to help you. And just know that you're going to use these ideas. You're going to look at the diagram. You're going to gather 3 congruent parts. You're going to prove the triangles are congruent using a postulate, and then you can already write the last line of your proof right away.